Hello children, welcome to 9th chemistry online classes. Is matter around us pure? In this chapter, we studied about different types of mixtures like solution, suspension and colloid. And today we are going to learn how can we separate these components of a mixture. How can we separate components from a mixture? Let us see. Separating the components of a mixture. So we know that mixture means it's contain two or more components. So how can we separate it? So in the day-to-day life, we are following many methods to separate the components from a mixture like filtration, hand picking, sieving, magnetic separation, etc. So the three things: filtration, hand picking, sieving. These every day we are doing the things. Okay, while we are making the tea or the rice, when we are making rice, cooking rice, that time we are taking, or by hand picking, we are taking the stones or other waste materials from that rice. Okay, so these methods we are using daily, and some other special techniques also there. That techniques we are going to learn in this lesson. So I will read that techniques: evaporation, centrifugation, sublimation, chromatography, distillation, crystallization, etc. So one by one we will learn. So first we see the technique evaporation. Evaporation. By this technique, we can separate the volatile component from its non-volatile component. And what is volatile component? Volatile means easily evaporate at normal temperature, and non-volatile means not easily evaporate at normal temperature. So a mixture contains both this volatile component and non-volatile component. We can apply this technique evaporation. Okay, so when we can do evaporation technique, the mixture containing volatile component as well as non-volatile component. Now we see one example. We take some ink. So ink is in which state? Liquid state. So any color, blue or black or red, any color, that ink contain that color or that dye, and that dye is mixed in the water. So here water, okay, you know that when heat water or boil water, that water part is evaporate. So in the same way, in the ink also, it contain the ink or dye part is mixed with water. So when we heat it, the water evaporate and we can separate the dye or that color substance. So here water is the solvent or volatile component, and color or dye is the solute, that is the non-volatile component. Now we see that method. Heat ink. Okay, so how can we heat this ink? So here once you can see one setup, that is a watch glass. So here it is the watch glass. So we take some ink in this watch glass, and this watch glass keep on the mouth of the beaker. So you can see here the beaker, and we keep this watch glass on the mouth of the beaker, and here that beaker contain some water. Okay, because we are not heat directly to the ink, we are boiling or we are heating this water. Okay, and continue that heating. So you can see that evaporation takes place on this watch glass, and after some time you can see that full liquid part or the solvent parts evaporate, and that residue or that ink or that color or that dye left here. Okay, so by this technique we can separate sugar from water, or from sugar solution by the technique evaporation we can separate sugar, and the same technique we can use to separate salt from water. And what is the basic principle? Here liquid vaporizes easily than the solid. Okay, so here we get dye is the solute particle and that is the solid, but that water, that is a solvent thing, that is liquid and that vaporizes easily. So that is our first technique, evaporation, separating the volatile component from its non-volatile component. Centrifugation. By this process, we can separate denser particles from lighter particles. Denser particles means heavier particles. So we can separate heavier particles from lighter particles by this technique, centrifugation. Example, milk. By the process of centrifugation, we can separate cream from milk. This technique we also do from our kitchen using the milk churner. It is made up of wood. Okay, milk churner. So using that milk churner, we can also separate cream from milk. So the same technique we are using in the lab using that machine. So in that machine, there is a provision for keeping many test tubes. And after keeping the test tubes, we can rotate that thing by manually or using electric connection or supplying electricity. We can rotate that machine. So after the rotation, the heavier particles forced down and settle down in that test tube, and the lighter particles we can see on the top layer. Okay, so by this method, centrifugation, we can separate cream from milk, and another applications also used in laboratories for blood and urine test. For that also we can use this centrifugation process. And another common thing is used in washing machine to squeeze out water from wet clothes. So that you know that the squeezing of water from wet clothes, that is the rotation, the speed rotation of that machine. So that also which method? Centrifugation. So the basic principle of this centrifugation method is denser particles are forced to the bottom and lighter particles stay at the top. That is the basic principle. So I am reading once again the method. Milk is put in centrifuging machine or milk churner, and the cream thus separate from milk. And applications: separating milk from cream, used in laboratories for blood and urine test, used in washing machines to squeeze out water from wet clothes. Basic principle: denser particles are forced to the bottom and lighter particles stay at the top. Using a separating funnel. This technique is used to separate two immiscible liquids. Immiscible means not mixed together. So I will tell one common example. Unfortunately, mix kerosene and water. What we will do, or how we can separate it? So in that situation, we can use a separating funnel. This is the separating funnel. So we will see how the separating funnel can separate the two immiscible liquids like kerosene and oil. So first we pour the mixture of kerosene and water into this separating funnel. Let it stand undisturbed for some time so that the separate layers of oil and water are formed. So after some time, we are not disturbing that setup. We can see the two layers. The top layer is kerosene and the lower layer is water. And here you can see one stopcock. So using this stopcock, we can close and open this funnel. So by opening the stopcock, the water, the lower layer of water come down. We can collect this water in a beaker and close the stopcock of the separating funnel as the oil reaches the stopcock. So after collecting the water, the oil come here. So that time we can close the stopcock. So that is the function or that is the working of separating funnel. So separating funnel is used to separate two immiscible liquids. It's very important. Separating funnel is used to separate two immiscible liquids. Example, oil and water or kerosene and water. Applications: to separate oil from water and to separate iron from iron ore, or the extraction of iron from iron ore. So in that time, the extraction, the lighter slag that is removed from the top. Slag means the impurities or the waste materials. So by the processing of this iron, some waste materials are there. So that waste materials have the density is less. So they come the top layer. So we can, using the separating funnel, we can separate that waste material or that slag from the iron. So that is that these are the applications of this separating funnel. And the basic principle is the difference between the densities of two liquids form two layers. So example, kerosene and water. So the densities having difference. Kerosene having less density than water. That is why kerosene you can see in the top layer. Okay. So today we studied three separating techniques. First one is evaporation, second one is centrifugation, and third one using the separating funnel. Okay, so that activity, application, principle, and that figure, very important. So all of you read your textbook very well. Only these three techniques. Other techniques also there that we will study in the next classes. Okay children, so thank you, all the best.